right, so we're going to be using TinkerCad to learn a little bit about circuits and explore circuit making. Once you're at tinkercad.com, if you have already an account, you're going to click Login, Student Accounts, and go in with Google. If you do not have an account, talk to your teacher about joining using a class code. Okay, once you're on the main screen, we're going to go to New. If you've used TinkerCad for 3D modeling, you'll recognize that we're not actually going to do a design today. We're going to be doing circuits. So you're going to select circuits, and that will open up a new window. If any of these little pop-ups come up, you can just X them out. And we're going to start by bringing in an LED onto our workspace here. So you're going to click the LED and click on it again here. Okay. Now this workspace works just like in the design area. If you have a mouse, you can use a scroll wheel to zoom in and out. And then you can also use the right mouse click, hold to move things around the space, or you can click on the actual object and move it around as well. Okay, I'm going to zoom out a little bit because we're going to have to bring a power source. Right now we have the LED, but in order to light it, we need a battery. So you'll see that we have a number of battery options right here. And we're going to use the 1.5 volt battery. I'm going to put it kind of like right underneath it. Zoom out a little bit so you can see the whole thing. Okay. Now an LED has two legs. Right, two little prongs to stick out. If you've used physical LEDs, if you've seen it, you will notice that one leg is a long leg and the other is a short leg. Okay, the long leg is the positive or the anode. In TinkerCAD, the positive and anode is the curvy leg here. That's the long leg that you would see. The short leg, the straight leg, is the negative. Okay, so we need to make sure we hook this up properly, otherwise the LED will not light up. So we got to go from positive to anode, from negative to cathode. And to see if our circuit works, we're going to go ahead and run a simulation. This allows us to see if what we actually created would work in real life. So let's go ahead and click Start Simulation. And notice, let me zoom in here a little bit for you so you can see. Notice that when I stop simulation and start again, you should be able to see that the light comes on, but it's barely on. And I wonder why that is. Well, the LED is actually rated as a 2.2 volt LED. That's how much power it works at optimally. But the battery we have here is only 1.5 volts, so it's actually not enough. So it's barely enough to turn it on. It turns it on, but it's kind of faint. So let's change it. Let's delete this. Let's click on the battery. Click backspace or delete on your keyboard, and let's bring a 9 volt battery. We're going to bring this one in right here. And if you can't find this one, if it's not right here, you can just type 9 volt in the search bar and you should be able to find this one. Okay. Now again, remember, the anode is a positive, so this one has to go to the red wire, the positive wire. Okay. And the negative wire has to go to the negative terminal here. Whoops. Let's see if I can get it on there. There it is. Okay. You can also always rotate it a little bit so it's easier to see. So they're kind of crossing each other right now. Okay. Positive goes to positive, negative goes to negative. Okay, let's do it right there so it's easier to see. All right, now we're going to run our simulation again, and we're going to see what happens with the LED. Remember, I told you the LED was a 2.2 volt rated. This is a 9 volt battery. Well, let's see what happens. Start simulation. Boom! That's what happens. Now, the LED wouldn't actually explode in real life, but it would go out. It would burn out, and you would no longer be able to use that LED. It's too much power for the LED. So if you ever hooked up a 9 volt battery to one of these 2.2 volt LEDs, it will no longer work and you're going to have to throw that out. Okay, so we know 9 volts is too much. So we're going to go to a 3 volt battery, which is a coin cell battery, which some of you may have used in the past. Okay, I'm going to put that right there. Zoom in a little bit so we can see. Again, curvy leg, positive. That's the anode. That's the long leg. If you had a physical LED in front of you, the cathode, the short and straight leg, is the negative terminal. All right, let's do our simulation one more time, and here we go. All right, it turned on. That's great. We got a little explanation mark. Let's see what it says. The current through the LED is 61 and 9/10 milliamps. The maximum is 20. The usable lifetime of the LED may be reduced. What that basically means is, hey, this is actually still a little too much for the LED. It still will work, but the LED may not last as long as you would want it to last. So ideally you want something a little less. And I will just kind of introduce something to you, but you don't have to do anything with it right now. There is something called a resistor, and I'll just bring it in here so you can see it. And the resistor resists energy, electricity, and flow of electricity. So putting a resistor in the circuit allows us to reduce the voltage. And depending on how strong the resistor is, we can reduce it by a lot or by a little. And we'll talk a little bit more about resistors in a later level. Okay, but for now, we are happy with this. We're going to keep going. Okay, we've got our battery, we've got our LED, and it lights up. All right, but right now the way it's hooked up is it would always be on. There's no way to turn it off unless we took the wire off of here, right? It would just stay on at all times. So we're going to add what we call a switch. Just like you have a light switch at home to turn things on and off, we're going to add a switch to this. So we're going to go ahead and select the wire that goes from the anode to the positive terminal of the battery, select it and click delete or backspace. And we're going to bring in a switch. There's something called a slide switch here. Let's bring in the slide switch. Okay, and then we're going to hook it up by taking the anode to the first terminal, and we're going to use the common terminal, not the terminal 2, the common terminal, and take it to the positive. Now let's go ahead and hit start simulation. There it is, it turns on. We still got a little warning light, but we're good, it's on. And now we can use the switch to turn it on and off. And that is a basic, simple circuit using TinkerCad. Awesome job.